Hi everyone, my name is M. Joshua Franklin, studying BTech Second Year in Information Technology. Welcome to my presentation on the GitHub Repository Tracker. Today I will be showcasing Java-based application that leverages the GitHub API and JSON parsing to retrieve and display comprehensive information about a user's repositories, making a repository management more efficient and streamlined. The GitHub Repository Tracker tackles the time-consuming problem of manually searching for repository information, streamlining the process for developers managing multiple repositories. This innovative application demonstrates the seamless integration of Java with development tools to access valuable information, showcasing the potential of API-driven development. By utilizing the GitHub API, this application can retrieve repository names, descriptions, and programming languages used, providing a centralized hub for repository information. Secure user authentication via GitHub API tokens ensures that only authorized users can access repository data. First, we have the GitHub configuration class. This class holds essential configurations like the GitHub API URL and a personal access token. The personal access token is crucial because it authenticates our request and ensures we stay within GitHub's rate limits. Without a token, GitHub restricts the number of API calls you can make per hour, which can be limiting if you are testing repeatedly. With a token, we can avoid hitting those limits and keep our requests secure. And now the second class is GitHub API helper. This is where the HTTP request is actually made. Here we use Java's HTTP URL connection to establish a GET request to the GitHub API. We also include the authorization header to pass our access token with each request. One important feature in this helper class is the use of connection and read timeouts. Setting these timeouts is critical because it prevents the application from hanging if there are network issues or if GitHub server is slow to respond. In our code, we set both the connection and read timeouts to 5 seconds, meaning the program will stop waiting if the API doesn't respond within the time frame. This keeps the application more responsive and prevents users from waiting indefinitely. Now here is how the code handles errors. We have added exception handling in the main class. If the program can't connect to the GitHub or if an invalid username is provided, it catches those exceptions and displays an appropriate error message. This makes the tool more user-friendly and reliable, as it would simply crash if something goes wrong. It's also a good introduction to handling potential issues with network connections, which is an essential skill in working with the APIs. When you run the application, it prompts you to enter a GitHub username. Once you provide a username, the program reaches out to the GitHub API to retrieve a list of repositories for the specific user. The data that comes back includes details like the repository name, description, and the primary programming language used. This information is then passed and displayed in a clean, user-friendly format. In conclusion, the GitHub Repository Tracker project demonstrates Java's seamless integration with the GitHub API and JSON parsing, providing a valuable tool for developers to manage their repositories efficiently and effectively. Thank you for your attention and look forward to your feedback.